Hi everybody, today our topic is the metric system. Not a topic new to any of you, I hope. So what our goal is for this lesson is to really make sure that everybody has the same skill set that they need to be successful during the year as we go through our problem solving and we're using our metric system. So our objectives are to differentiate between fundamental and derived units of the metric system, and also to be able to convert units of measurement, one type of length to another type of length. That basis of being able to convert units will also help us as we start doing our problem solving, where we look at something called dimensional analysis, where we can use our units also to help us know whether or not we're solving the problem correctly. So if we're pretty good at being able to convert measurement, we might be able to use that skill to be able to confirm that our answer is correct and maybe give us a little bit of a comfortable feeling that we've actually done our solution correctly. Okay, so we all know that most science uses math as a language to help describe the phenomenon, the events, the topics that you're studying, and physics really does. Right, so this is probably going to be one of the most math-intensive science classes you've had. Why do we have the metric system? Well, we found that scientists wanted to be able to share and communicate the information effectively from the observations that they made, and they really wanted a standard measurement system. It's required to make things consistent. So we use what is called the SI or metric system, and it's pretty much the standard measurement system that we will be using for science. Right, there are 7 fundamental or base units in the metric system, and then you can see them right here. The nice thing about the metric system is all the units are based on powers of 10. So if you want a smaller unit of length or a larger unit of length, the only thing that you have to do is change the unit by either dividing or multiplying by a power of 10. Unlike in our English system, where, for example, let's take our measurements of length, we have 12 inches in a foot, 3 feet in a yard, 1,760 yards in a mile, or 5,280 feet in a mile. Those conversion factors can become quite cumbersome. So it's nice from the metric system where everything is based on powers of 10. And when we have those powers of 10, we just represent it by using a prefix. Each base unit describes a single dimension, such as length, mass, or time, one unit of measurement. The most common ones that we will use in class this year are the meter, the kilogram, and the second. And you can see that they are the base units for length, mass, and time. When we have these units in their combination like this, we also have what we call the MKS system of SI units, which means everything is in meters, kilograms, and seconds. That's helpful to be able to make sure that you establish everything's in meters, kilograms, and seconds, because you're going to find when we start talking about derived units that those derived units are based on making sure that the fundamental units are meters, kilograms, and seconds. There's also another system that is used quite frequently, and that's called the CGS system, which is centimeters, grams, and seconds. But we won't be using that in class. The other one that we might use during the year is this electric current one, the ampere. When we start talking about electricity, that will be the other unit that we use. But the rest of the ones for temperature, amount of a substance, and intensity, probably we won't talk much about. Okay, so let's talk about our meter. The meter is a measurement of length. A meter, a meter stick is about a yard. All right, we have meter sticks in class that we'll be using for our measurement. Usually they have 2 sides. This is the metric side, the meter side. This is the English or the inch side. All right, remember, always use this side. For measurements smaller than a meter, we use those centimeters and millimeters, these little guys that are in here. So a 1 meter stick is broken up into 100 centimeters. Or if you notice, each centimeter then is broken up into 10 millimeters, which means each meter stick is also broken up into 1,000 millimeters. Micrometers we might use in as measurement when we calculate measurements, but I doubt there's anything that we're really going to use where we have to actually measure something in the classroom or in our lab in micrometers. For measurements that are larger than a meter, we use kilometers. And if you're curious, a kilometer is a little more than a half of a mile. All right, the kilogram is a measure of mass. You might have used one of these triple beam balances back in chemistry class when you were measuring the mass of matter or mass of a substance. For measurements smaller than a kilogram, we generally use grams and milligrams. Grams is the unit of measurement those triple beam balances measure in. The kilogram is the only base unit that has a prefix. If you notice back to that table of the 7 base units, none of them had a prefix of the kilo, milli, centi, except for the kilogram. And that's because the gram itself is such a small unit of mass. A gram is about the mass of a paperclip, that it doesn't seem practical. If we want to describe real world objects, just think if we had to describe everything in terms of how many paper clips it weighed. Everything would be a pretty huge number. If you're curious, a kilogram is about 2.2 pounds then in our English system. All right, our last unit of measure that we'll be using mostly during the year is our measurement of time. Our base unit for time is the second. Unlike the other quantities in the metric system, the quantities of time are not based on powers of 10, and I think that's simply because time was so well established before the metric system came along, it made no sense to try and change time. So when we start talking about measurements of time that are longer than a second, we use minutes and we use hours. Remember that there are 60 seconds in every minute, 60 minutes in every hour, and if you do the math real quickly, you might be able to come up with a shortcut that there are 3,600 seconds in every 1 hour. Okay, so if we work on those 7 fundamental units, what happens when we start talking about other units? Where do they come from? Well, derived units are combinations of units that result resulting from performing mathematical operations. So when you talk about some of the derived units that we might be talking about in class, something like speed, we take a distance divided by a time. So the unit of distance would be meters, we divide it by the time in seconds, and we get meters per second. Acceleration is something else we'll talk about, meters per second squared. And we'll talk about how we get that in class. Some of the derived units get their own name, right? So when you get a clump of units together, sometimes they're just a little too confusing, or sometimes we like to honor somebody who did scientific work in the area that came up with those measurements. So for example, something that we'll be using during the year for force is a Newton, but a Newton is really a kilogram times a meter divided by a second squared. You can see some of the other examples of derived units that we might be using in class throughout the year. The important thing with derived units, though, is to remember that regardless of how you get to that clump of units, the unit is still the same. The derived unit is still the same regardless of the path of how you got to that derived unit. All right, so hopefully you realize for smaller or larger base unit measurements, we use those prefixes. All the prefixes indicate a power of 10 to multiply or divide, and these are all of the ones that are pretty common that we might be using. Our most common ones that we will use through the year, we might use that kilo, centi, and milli. So you can see that there's not a whole lot of them that you might need to know. So if you're one of the King Henry fans, you might have to drop a few of your letters from your acronym. You can see that all of those indicate whether or not I'm multiplying or dividing by 10. Any place where I'm multiplying by a power that has a positive exponent, the number is bigger than 1. All right, I'm getting a larger unit of measurement. Anywhere where the exponent is negative, the number is smaller than 1. I'm getting a smaller unit of measurement. All right, so let's look at using some of those prefixes in order to find out some of our conversions, if we want to start looking at things in different types of measurements. You'll have to forgive me here. I'm still working out some of the ways to be able to draw some of this, so I sort of quickly went through and made sure that they were here beforehand. So let's look at an example. We want to convert 2,480 meters into kilometers. So some of you may already know that sort of ladder method, or some of you may know the parentheses method. But the goal out of this is to make sure that what you're doing as you multiply or divide, you are doing what you need to do by always multiplying your given by a ratio that is really equivalent to 1, but it's just changing your unit that you're actually measuring in. So for example, if I look at this one here, I want to start with my 2,480 meters, and I want to get it to kilometers. So the way I do it is I make sure that if meters is up on the top, I want to make sure when I start talking about my equivalent ratio here, because 1 kilometer equals 1 times 10 to the third meters, and we see that right here. So I'm not multiplying the measurement by any number to change it. I'm really multiplying it by a ratio that's equal to 1. When I do that, I just am changing the unit of measurement. So I start with this guy up at the top. Whatever I want to cancel out, I put down the bottom. So when I actually multiply these across, my meters and my meters will cancel out, and I'll be left with that unit of kilometers. Now all I have to do is the math. The 2,480 times 1 divided by 1 times 10 to the third would give me 2.480 kilometers as my conversion. Now, some recommendations that I might give you as advice. If you're already good at this, don't bother trying to figure out. I'm not trying to change the way that you do things. Stick with the way that works for you. As a matter of fact, you will find me in class not doing what I'm going to recommend to you here because of the way I've done it for all the time I've done it isn't really this way. But I'm going to recommend it to you if it's something that you're still a little bit uncomfortable with. When you write your conversion factor, always use this guy, these notation, right, for the prefix, and then always do the conversion part in your non-prefixed unit. So you can see here, I have meters, I have kilometers. The K in here got replaced with the times 10 to the third. So that way I know which way I'm going. I'm not having to remember, is it 1,000 kilometers in a meter, or is there 1,000 meters in a kilometer? If I can use these prefix powers over here and simply substitute the prefix, that K, for the power difference, all of a sudden I get my ratio pretty easily. Hopefully that makes sense, and if not, we'll do some more examples in class. Don't worry about it. All right, so here if we go the other way, here's another example. Here we're going from kilometers to meters. Same type of thing. I start off with my initial measurement in kilometers. I create my ratio where it's really equal to 1. I have the kilometer on the bottom, so it's going to cancel out. Again, I write my meters on the top, which is the unit I want to come up with. I replace my kilo prefix with the times 10 to the third that it represents. And now I can get enough information that all of a sudden I see I should get 5.375 meters. You might also notice when you go from a measurement that is, or a unit of measurement that is larger to a unit of measurement that is smaller, your number gets bigger. And the opposite is true. If you go from a unit of measurement that is smaller to a unit of measurement that is bigger, your number should get smaller. So that's another way to sort of remember what you need to do. Okay, so what happens if you get a conversion that you don't know a direct conversion factor for? I don't know how many centimeters there are in a kilometer as a direct conversion factor. You might. But I always go back to my base unit. I always know everything with respect to a meter. So if I know that, I can always make a path through that meter in order to be able to do my conversion. So you can see here I have 52,500 centimeters. How many kilometers is that? Here's my known. I want to first get rid of the centimeters and take it to that base unit of meters. All right, so here my centimeters will go away, and I have some math that now I know my answer would be in meters. Well, now I want to go from meters to kilometers. Again, I can do something with my meters here and get me to my kilometers. So my kilometers are my final units that my answer will be in. Now I just have to do the math. This guy times this guy times this guy divided by this guy times this guy. Please watch your calculator with order of operations when you start doing some of these things. So this should get me 52500 kilometers. And you can see, just like I said, the number, I went from a smaller unit of measurement, a centimeter, to a larger unit of measurement, the kilometer, and as a result, the number part got smaller. All right, we're going to be doing, especially in the beginning of the year, a lot of conversion between the metric system and the English system of units. And you may say, why? You told us that we use this metric system because it's nice and it has powers of 10 and it's what scientists use. But the fact of the matter is, it's not what we use in our everyday life. So if I'm talking about something that is a distance, if you go 3 miles from home, you might be able to imagine that in your brain and see if something is reasonable. But when I start talking kilometers, we just don't have that way of checking ourselves to make sure that that answer makes sense. So initially, in the beginning of the year, we might be doing a lot of especially motion problems going back and forth between the English system and the metric system. And it's simply because we need to get that gut feeling about whether or not our answer makes sense. So just like the metric system, where you have conversion factors, you also have them here. No different, and the process is no different. So you can see here I have 50 miles and someone's asking me to convert it to kilometers. So if all of a sudden you look over here and you want to do 50 miles and convert that into kilometers, we have a conversion factor. We know from right here that 1 mile is equal to 1.609 kilometers. So our setup is no different than it was with our other conversions. We take what we have, we put it on top. We have 50 miles. We now write a conversion factor that is equal to 1, miles on the bottom, kilometers on the top. My miles will cancel out, and I'll end up with kilometers of 80.45 kilometers. And remember, I said that a kilometer was a little bit more than a half a mile, so it would make sense that we would have more kilometers than we would miles. Something I'd like to make sure that you realize too as we go through the year, miles. M jumps up a lot as a letter in class. If you see M as a measurement unit, it means meter. I will always write out miles as a word, or you might see it as mph, miles per hour, if it's used as a speed. And that's simply because even if you use something like mi, you start getting confused with those things called minutes and time. So in general, always try and make sure that you're writing out those customary or English system units, because sometimes we don't want to get them confused with our metric units. All right, so sometimes derived units are going to require a unit conversion, meaning derived unit, it might have a unit on the top and it might have a unit on the bottom. So you can see this is a derived unit for speed. How fast is something going in meters per second? So again, remember I said if you see that M, it means a meter, not a mile. Per second, the division sign means per, and we want to convert that to kilometers per hour. So again, we start off with our little ladder method, 32 meters on the top. Our per, if you want to think that as a 1 second on the bottom, that's fine. That means we travel 32 meters every second. Generally, I pick the one up on top first to try and get rid of. So I'm going to convert my meters to kilometers. That will give me my kilometers. And then I'm going to try and go from seconds to hours. I'm going to do seconds. I remember that there are 60 seconds in 1 minute. All right, but minute is not what I'm looking for. I'm looking for hours. So I'm going to now do also that there are 60 minutes in 1 hour. And I'll be left with my hour on here. So that now if I do my math, I simply take my 32 times my 60 times my 60, and I divide that by that 1,000, or that 1 times 10 to the third, and I would get 115.2 kilometers per hour. Okay. All right, and the last but not least is one of these derived units where we're going between English system measurements, those things that we're going to be used to, and metric system measurements. So 55 miles per hour, how fast is that, or what is that equivalent speed in meters per second? And here's where you can see I said that the M and the M, you really have to watch. The only time I will express miles as an M by itself, meaning not the word miles, is when it is in this little, I don't know if you would call that an acronym or a shortcut of saying miles per hour. So that's the only time you will see it. But if you see that mph, that is miles per hour, not meters. All right, so we would start off again, writing that off. Our 55 are miles per hour. I want to go from miles to meters. So I will cross out my miles. I now have my meters on the top. All right, and I have to convert my time. So hours to seconds. Again, you might not know a direct path between hours and seconds, but you can go through that intermediate minute. So I cross off my hours. That gives me minutes, but I still don't want minutes. I have to cross out my minutes and gives me my seconds. So you can see I have my now units of meters per second. All I have to do is my multiplication and division of 55 times my 1609 on the top, divided by that quantity. Make sure you realize your order of operations as you're doing things using calculators, and we'll talk about that a little bit about class. If you're not using parentheses around your 60 times your 60 on the bottom to make sure your calculator knows to do that multiplication first, remember you're doing division on each one, so it should be divide by, divide by. Watch how you do your order of operations. And last but not least, so this would come out to be about 25.7 meters per second. Okay, hopefully that answered any of the problems that you might have had about conversions, and we will get a lot more practice in class.